Welcome back to Track D, AI and Machine Learning Summit. Today we're going to be, this is the last session for the day within this track. We're looking at using AI for digital document accessibility compliance with Ian Smith from codeMantra. Ian is based in India and will be initially with a video, and then he'll be answering questions. So do ask questions via the chat. I'll queue them up and provide the answers just as we have done before. So I'll turn it over to the video at this point.
Using AI for digital document accessibility. Hello, my name is Ian Smith, Director of Accessibility Platforms and Solutions at codeMantra. Today I'd like to talk to you about using AI for digital document accessibility compliance. Imagine a world such as this. Imagine a world such as this. There are over 7 million people in the United States and over 280 million in the world today with some type of visual impairment. Or even this, which represents the experience of the more than 30 million adults in the United States with dyslexia. These are only a few examples of why we have leveraged machine learning to help everyone be able to utilize content regardless of ability, because we make the content within documents accessible. So, what does it mean for a digital document to be non-compliant? So what I'd like to do is do a compare and contrast against a sighted user looking at a given page represented on the left and an assistive technology experience represented on the right. So on the left, we can see a PDF, standard article, and for those of us who can read it, we just understand that the title starts with outcomes and costs of school support. We know that because we've read many articles. Therefore, a large bold font at the top of the page typically indicates that's the title or the beginning of a particular article. We're also able to understand inherently that the names listed below the title are likely the contributors or the authors of this given article. We also know that the abstract, being in the shaded box, is meant to be read in isolation, and is just that, it's the abstract of this given article. We go on to be able to read and understand that this article contains many sections, as indicated at the bottom of the page. By introduction, we can also traverse the multi-column layout that's represented at the bottom of the page. Again, all of this because we have just learned to read this type of construct over a long period of time. However, users of assistive technologies don't have all of those visual cues. They're simply presented with a text-based version of that content. So now, a non-compliant version of this document, we step into that experience, we'll quickly see that the introduction, which is at the bottom of the page, is the first piece of content that users presented with. Obviously, that's not the preferred reading order, and was likely confusing to the reader once they get further into the content and come to the next piece, which is, again, a slug at the top, talking about this particular version or release of this article and the digital object identifier of where it can be found. So you can imagine as you're reading along, having that piece of information presented is confusing and would likely disrupt your reading flow. Next, it finally comes to the title of the article, which, as we understand, should be the first thing presented to that user. Now it finally comes to the abstract. As you can imagine, trying to read documents in this way, this is a terrible challenge and really makes this type of document useless to the user. Useless, or at least very frustrating to use. tables. If you can imagine that first page was challenging, imagine trying to read a table in a similar fashion. So the left-hand side, we see that table. We can see it, we know how to navigate and understand what is in that table because it's structured as that. However, the experience for these assistive technology users on the right-hand side is much, much different. There's no sense of or indication that there is a table within this content. Sure, the table title is indicated there in a string of text, but after that, it's just a series of chunks of content, not structured as a table. And if we take a moment and think about how we consume content today, we're often not reading cover to cover. And typically we never read a table start to finish. Tables are data tables. We're meant to look for certain data or information within that table. And we use things like column heads or row heads to find exactly the information we're seeking. So in this assistive technology experience, that's virtually impossible. First of all, you don't understand that there's even a table short of that statement. Then to try and navigate is impossible. That's again, long strings of text. So these kinds of experiences of for users of assistive technologies is again why we went down the path of making use of machine learning to bring documents into compliance. So how do we exactly go about that? The next few screens are visual representations of the results of various machine learning models that we've developed. When we look at a page, again, as cited users, we understand that there are various chunks of content. We also understand, again, based on various visual cues, that there's headings, there may be lists. This particular page has an image at the bottom, and the multi-column flow. We also understand how to read that logically. Our machine learning models break the content down in a very similar fashion. It first analyzes the page, breaks down the respective chunks, begins then looking at various cues, nearest neighbors, proximity, all of these things to determine what is the most logical structure for the content. And again, when I refer to structure, I'm talking about your heading 1, 2, 3, and so on, as well as any list items and images on the page. The next thing that it will do is to take that structure and begin applying the most logical reading order. Those two things together is what provides a highly usable and equal experience for users of assistive technologies. Images, equations, sometimes tables, and hyperlinks within content should have labels or alternative text versions for them. Again, a blind or low vision user of assistive technologies needs those descriptions and labels to understand these visual elements and what they represent within the context of this particular piece of content. So here we can see that alternative text versions have been supplied for the various visual elements in this document, such as that first photograph of the store entrance. Our machine learning models also identify formulas. Formulas within PDFs are virtually unable to be read by assistive technologies. Therefore, the structure is very important to PDFs when there is formula information contained within it. So our machine learning models will identify the existence of an equation. And in doing so, we're able to break that equation down and generate two results. The two results that we create, one is a syntactic alternative text version. Those text versions are used for PDFs. That's the only way that a user of an assistive technology, when encountering a formula in PDFs, is able to understand what's there. The assistive technologies see that formula tag, knowing that then there will be an alternative text version supplied for it, and presents that description to the user. The second thing that we can generate is MathML. MathML is a markup language used typically for HTML outputs or other markup languages and rendered either on web pages or elsewhere. These two outputs, the syntactic description as well as the MathML, provide very similar experiences to these users of assistive technologies. Tabular data tables, they also need to be structured fully, just like I mentioned the logical reading order as far as the flow of content. And oftentimes we're seeking bits of information. In order to do so within a table, that table must contain the complete tagging structure, which would then allow a user of an assistive technology the ability to properly navigate that table. Essentially, when their assistive technology encounters it, it announces the fact that it has 5 columns and 3 rows. That starts to paint that picture to these users of the complexity or the structure and the depth of the table that exists. When the column and or row heads are structured properly, it will then announce those to the user as well. And through the combination of that, they're able to find the piece of data in the given data cell that they're looking for, just like we do as sighted users. So again, without the existence of the structure, those users are very challenged greatly in making good use of the table data cells. So, accessibility compliance. There's an international standard, Web Content Accessibility Guidelines, and there are a variety of tools that allow users to check their documents against this international standard. There are applications, there's the ability within Word to check your Word documents. There are several PDF utilities. Acrobat itself can assist in checking the accessibility compliance of your PDFs. These are all one-off application-specific tools. They are useful as in when you're creating content. In the event that you have a large collection of content, a more scalable solution that is able to run compliance validation against multiple formats may be of great benefit. Also, monitoring compliance of your website. Often these documents end up on a corporate website, agency's website, and you need to constantly monitor that to ensure that that site remains compliant. And so there are several success criterion, over hundreds of success criterion that must be met in order for a document to be compliant. And those are often grouped into 3 respective categories: alternative text, properties, and structure. I already discussed a little bit about the alternative text versions. Properties are things typically like the title, the author, the subject and keywords for a given document, the native language of that document. All of those things aid assistive user technologies to inform the users, one, of the title of the document. It also acts upon the language setting in order to pronounce words properly. Structure is what I've been talking a lot about, which is ensuring that it can allow a user to properly navigate through the document, just like we navigate through chunks of content to find the information we're looking for. So within the alternative text, again, I had mentioned that each image or formula should have a description. So these compliance checkers should present that information to those users. It's an easy way for them to see quickly at a glance what the description is, ensure that it's truly appropriate and conveys the necessary meaning for those users to get the most out of their content. And the structure. And there's a lot of technical nuances, specifically within PDF, that are required to fully tag and structure that document properly. If we think about lists, lists are made up of list items, list labels, and list body elements. So these compliance checkers need to check all of that thoroughly. There are also even attributes applied to lists, which indicate, is it an ordered list? Is it an unordered list? If it's ordered, is it ordered by upper alpha, lower alpha, upper Roman, etc.? Again, as sighted users, we can see those things, but to the users of assistive technologies, they need to be able to be presented that by the assistive technology that they're using, and that's only able to do so if that information is made available within the document structure itself. So now that we've kind of experienced what it was like for users for non-compliant documents, we've stepped through a little bit about how machine learning was used to structure the document, the importance of these alternative text versions, ensuring that the documents are compliant. Now that we've achieved compliance, let's look at those results and the differing experience for these users now that they have a compliant document to work with. So the same article on the left-hand side, but now you can see that the right-hand side represents a much different experience for these users. The content is ordered in its most logical reading order. The assistive technology finds that again through the structure that was created. They are now able to navigate this document through the use of the headings that are there. They can determine which section it is that they're most interested in and jump to that location. In a non-compliant document, the best thing that they could do is a keyword search. So you could imagine trying to navigate through a document only through keyword searches. Obviously, having heading structures, which breaks it down into its various parts and sections, gives a much better experience for these users. Next, the authors and the contributors are identified. Some of those authors and contributors in this particular document have links about other reference works that they had created. It's also made available to the user now. The next section is so all of that logical reading order, again, that we can see visually, was given to these users through a combination of the structure and the logical reading. This example of the table, very, very different experience. The right-hand side now has the data that's there, starting off with that section about data analysis in the following paragraph. Then it steps into that table structure. And as I mentioned earlier, when present, the assistive technology is able to provide that information to the users. It maps out that table structure for them and announces those things, as I had mentioned, the column heads, the row heads, and will allow them to truly navigate that document. As we can see, this particular table has lists within each of the data cells. So now, when entering that data cell, after having been able to navigate there because of this structure, the user is immediately told that they've entered a list with X number of items. In case on the screen, it's going to announce that it's a list with 2 list items. All of this is extra detail that we see, but they need to have presented to them in various ways. So it'll tell them that they've now entered list item 1 of 2 or 2 of 2. Again, so they know where they are in this content and they're able to continue navigating and reading just as we do, again, sighted readers. So I hope you found this helpful to gain a bit of an understanding about digital document compliance, the importance of it, the impact of it, and the mission behind what we've done for the last 3 or 4 years to utilize machine learning to bring this, to solve this problem. Again, there are trillions of PDF documents out on the internet. It's a very dominant format. It's very good at what it does, which is to allow information to be shared across various platforms. This is the missing piece to making those documents usable by anyone, regardless of the ability. So again, I thank you for your time. It's a pleasure speaking with you.
Contact information there for you as well. That's always good to have. I know I like to have that after a conference. Ian, you talked to applying machine learning to accessibility, and you spent a good amount of time talking us through what it means to make a document accessible. Did you face any particular challenges when you were building the machine learning models that helped you do that? I mean, anything you want to talk about there? Sorry.
Yeah, absolutely, Ed. So there were major challenges. Everybody creates documents differently, different layouts, different structure, different font sizes, different colors. So the data set that we had to aggregate and utilize to train up these models was quite extensive. We did start with a pretty common data set, PubliNet, and it's the largest layout analysis data set out there, and made use of that as a foundation, and then through our own works had aggregated many other different document styles. But so being able to accommodate that was one challenge, but then you also look at within a single document, people may have combined multiple documents into a single file, right? So think about, I don't know, bid submissions, right? So some agency or some industry was requested a bid and they needed to make that information public once the bid was awarded. They've aggregated all of the bid responses into a single document. You, me, and everybody else creates our own bid, format, if you will. And so again, we're challenged by the various heading sizes and the different list styles and things like that. So we really had to train the machine learning to look at the entire document, but not aggregate all of that information, to look for similarities from page to page. And once it found a very disruptive or a distinct change, then maybe consider a new set of heuristics for the subsequent pages. So that was definitely a challenge because we were getting some quite diverse results before we took that approach to really segmenting even the document down into pages. But then trying to stitch all of them back together to get a conducive document start to finish so that you do have your heading 1, 2s, and 3s throughout the entire document. Even though your heading style may have been very different visually than mine, structurally it needs to be presented to these users, your heading two is the same as my heading two. So there were some challenges there. The other thing that we're doing in conjunction with the layout analysis is a bit of content analysis. If we think about lists or even continuing paragraphs, lists have different bullets. As I mentioned in the video, they also have, it could be an ordered list, which has your upper alpha, lower alpha, Roman, whatever you selected for your particular list. I mentioned that that attribute needed to be added to the structure. So we're doing some content analysis. When we do find a list, we look for those bullets then, or the numbering or ordering, and try and make sense of what the user put into their document. Again, was it an upper Roman number set? If yes, then we can transform that into an attribute that's applied to that tagging structure. Paragraphs, a little bit of content analysis there. If nobody, or we don't always have paragraphs that end nicely at the bottom of the page or at the bottom of multi-column flow, right? They often break to the next page or the top of the next column. To do this correctly, those two chunks really need to be a single paragraph. So we do some joining of those two chunks of content, join them into a single paragraph structure element. So that's, again, we're another instance of where we stepped into some content analysis to make sure that our resulting tag structure is clean and appropriate.
I'm hesitant to ask this question, but I mean, were you targeting a particular level of WCAG compliance with the project, or were you just using that as a set of guidelines to help you guide through the work that you were doing?
Super question. So, because of the whole pandemic and even prior to that, right, a lot of schools and everything has gone virtual, right? These events even. But so there's the demand and the need rather for these documents to be made available virtually, really pressed us to make drastic improvements or increased in accuracy for our models. Prior to that, we just looked at it as a means of getting the heavy lifting done. Because prior to a solution like this, everybody was doing this manually. They were using tools like Acrobat or some other plugin and whatnot, and it's a very laborious and manual process. So we wanted to try and overcome that challenge, because as I mentioned, there's 2.7 trillion PDFs or something out there. Nobody has the budget for somebody to do that manually, right? So there needed to be a mass means of making these documents better than they were. So we did use the WCAG standard as a set of guidelines as to what we needed to achieve, and then have continuously progressed in making our accuracy better and better over time, again, with bringing more document styles in, tweaking some of our heuristics and that content analysis that I referred to. All of these things have allowed us to achieve very good results. To be honest, it will not produce a fully 100% compliant document. Anybody in the accessibility space will say that there has to be someone to review, and a human needs to verify some of these predictions that a machine has made. The other thing I learned over time was that, I'm not the one to say to anyone what their chosen level of compliance is or should be. They themselves need to decide that. So we're providing them a means of doing a lot of the heavy lifting, getting their documents much better than they were, and then allow them to choose whether they take them to full compliance or not.
Yeah, that makes perfect sense. You do want to meet the needs of where a client is at or where a particular project is at, rather than setting some standard for yourself that is more ivory tower. One of the questions that came in was around what was more challenging to achieve compliance standards, images or text. Did you find language or image recognition to be more challenging?
Absolutely, the language. um, it's been quite, we were very successful at the onset because of all the computer vision stuff that's available to identify images or charts and graphs and things like that. So those types of objects, the data set and the models that are out there are quite good at achieving that. The text analysis is what has really been the most difficult for all majority of the reasons I mentioned earlier. Every document is unique. Where we did find major success is for a series of documents that utilize a very similar construct. I use the word template loosely, but if the structure and the presentation of a document is very consistent, then we can kind of tune our models to best understand that specific document style, and that greatly increases the accuracy of the results.
Yeah, no, I can see that. I know one of the approaches that we've taken to try and improve processing and ingestion of content, particularly the PDF formats, has been to use image recognition rather than text recognition. So we'd actually process the PDF as an image in order to get that structure that you were talking to in your video, and using that to leverage or to improve our models. Um, has that been an approach? I mean, I'm way off the reservation at this point. This is really a question that's very much Ed, right? This is Ed's question. But did you do anything like that with the models that you were working with? Did you try that kind of an approach, or was that not something?
Oh, we absolutely did. So we do actually take each page, convert it into an image, and use image recognition versus text extraction and analysis in that capacity. And that proved beneficial. We did that several months back, and we have seen a drastic change in our results after having made that shift. So yeah, that approach has been quite successful.
Let me see if we've got anything else coming in here. You mentioned MathML for equations. Is that similar to LaTeX, or is it different?
No, it is similar. LaTeX has been around for quite some time, and it's used to actually create a lot of that scientific material, mathematical material and whatnot. MathML is predominantly used in your other markup languages, as I mentioned, HTML or EPUB. For a lot of educational publishers, their advanced algebra books and trig books and whatnot are all in EPUB format, and it requires that MathML. So it's a math-specific markup language, and there are a lot of transformations to go from LaTeX to MathML. Our biggest challenge, though, is, as I mentioned, when it's in a PDF. PDFs, were fabulous at doing what a PDF was supposed to do at the onset, which was preserve the look of that page, no matter where it went. Right? That was the original intent, and it was perfect for that. Only when somebody said, "Oh, I need to get the information back out of a PDF," or have it be read by some machine, that's when things started to fall apart. That's actually when they updated the PDF specification to allow for this tag structure to exist, which then allowed that content to be machine read or extracted in a much better format. But equations are still probably the toughest aspect of that exercise, because it's really a set of encoded glyphs that, I don't know, if anybody's tried to copy paste out of a PDF, you never know what you're going to get. Sometimes it looks good, other times it's a bunch of gibberish. Equations are most always gibberish in that fashion. So we really focused hard on that aspect. Identifying the equations was probably the easier part, but then doing that transformation, analysis and transformation to both the syntactic description as well as that MathML. But it's provided, a great benefit to these PDFs and these users rather, of these PDFs. Otherwise, that math is basically useless to them.
Had a question again from the audience around any thoughts with regard to challenges or benefits as they pertain to people with disabilities.
I mean, I started my career path with accessibility about 4 or 5 years ago. It was astounding at how many assumptions I had made as to, or how many things we take for granted, being sighted or able to actually see and use content. It was astounding to understand from users of assistive technologies just how troublesome it is for content not to be compliant. So challenges are massive. They, as I kind of showed in my video there, that slide or two that had, basically it's raw text. A document that is non-compliant is nothing more than a mixed up bunch of plain text. And so the challenge for them is that they cannot navigate like we do. No, unless you're sitting beside the fire reading a novel for leisure, you're oftentimes not reading cover to cover. We're all looking for bits and bytes of information. Right? I got 5 minutes. I'm going to go grab this, or I'm going to look for that. It's impossible for them to do so without these documents being compliant. So the benefits there are as they truly have equal use of these documents and access to the content in very similar fashions that we do. I would say those are the two drastic challenges: unable to make use of it, and the benefit is that they now do have access and equal use of that content.
I got a question from Mary D. She says, "Hi, Ian. Thanks for being here. Paul Nelson talked about documents written by GPT-3. Does that have any effect on the work that you're doing?"
Not just as of yet, but interesting segue that I talked a little bit about us doing content analysis. We have considered extending that in and making use of something like GPT-3. Because as we're, one of the other challenges, I guess, for users of assistive technologies in these documents that I did not mention yet is sometimes the text itself, spaces disappear, spaces are introduced. You think about how many lines have hyphenations at the end. Sometimes those don't get removed. And so when an assistive technology reads the content, it encounters a broken word because randomly there was a space introduced. Or like I mentioned, maybe a hyphenated word remained hyphenated when it didn't need to be. So there's a lot of content integrity challenges. And one thing I've considered to try and do is make use of more natural language processing to try and, once we've created the structure, we can make use of something like that to actually go through the content that we've now applied the structure to make sure that it makes sense. Um, Otherwise, yeah, it's great. It's structured now, but it's still a bunch of gibberish. It would be great for these end users to have a nice, clean string of content that doesn't have these broken words or words that have been merged and things like that. So I have considered making use of those types of models to clean up the text.
I mean, that makes a lot of sense. I know whenever I work with PDFs, the content you get back out of them is as you described, broken up, hard to find hyphens, words are separated, words are connected. I used to work in the enterprise search arena, and that was always a challenge with PDF files. And even if you could get them into the index, the challenge was making sure the text was good. Of course, the challenge with GPT-3 is going to be making sure that the text that comes out of it is accessible from the beginning.
Right, correct.
Okay, so we're coming up right on the end of the session. There is a chat room in the networking area called come on, track D, and that's where anybody who's been part of the sessions goes and just kind of has an opportunity to ask questions of the speakers and the participants and so on. It's a little bit of a kind of a birds of a feather for the track that we're on as a virtual conference. So I'm going to recommend that everyone take the time, go join that networking session. And we'll pick up again. I think there'll be, we start Data Summit again tomorrow with new keynotes and everything. So if you could complete your surveys for the participants or for the speakers who've been providing this great content, and I really appreciate your time today. This was interesting to me because I used to do some accessibility back in the day, and hearing about how you've been able to apply some really emerging technologies to this, that's been really that was really inspiring for me personally. So thank you, and I wish you luck in your travels coming up. Hopefully that all comes together for you.
Indeed. Appreciate that, Ed. It's a pleasure.
Thanks.